Well, what we're going to do here is to find the static and dynamic equilibrium in a system. Our system is a rotatory disk. And for the static equilibrium, what we have to see is that the sum of all the forces in all axes are equal to 0. In this case, our disk, the only forces that it's applying on the disk is its weight. And if the disk is homogeneous, then all the forces in a differential portion of the disk are going to be 0 with the bearing of the rotor. But in a dynamic system, we are not only looking for the weight, but the moment around the axis when the disk is rotating. Again, if the disk is homogeneous, then therefore the sum of the forces is going to be 0, because all the tangential forces are going to be equal in all directions, so the disk will be in dynamic equilibrium. So first we have our disk alone, and if the disk is homogeneous, as I've said before, the static and dynamic equilibrium should be correct, and the system must be balanced. So this is a dynamic equilibrium where even if the disk is rotating, it shows no other motion but the rotation. And now we've added a certain mass to the disk, so it is no longer homogeneous. As we can see here, it is statically balanced, but it is only because the bearing is supporting the extra weight on the disk. But this is not going to be the same while it is rotating, as we are going to see now. As you can see, it vibrates, so it means that it is not dynamically stable. Our disk with the added mass is represented here in this picture. As you can see, here we have the added mass, and what it is going to do is to make a tangential momentum around the axis that is going to be extra to the normal weight of the disk, causing it to be unstable while rotating. So what we need to do is to add extra masses in other points of the disk in order to reduce this momentum around the axis and make it 0 again. Well, the final model is going to be something like this, where we have one big mass on one of the sides and 3 masses on the other side. The model is right here, and let's try it rotating and see what happens. So now let's try our model once we've balanced it. As we can see, the vibration is minimal compared to the one that was not balanced. Let's see it again for reference. So let's see our unbalanced system again, just to compare. As we can see, it vibrates a lot more than the balanced system. So that's all. Thank you for watching.